Hello everyone, lovely to see you all. I'm Becky Francis, Director of the UCL Institute of Education, and thanks so much for joining us on this really cold evening, so a warm welcome to the IOE. And once again, I'm delighted to be introducing one of our professorial public lectures, which is another opportunity to share and celebrate our senior colleagues' research. So first of all, just a couple of the usual housekeeping matters. Hopefully you'll have seen the login instructions as you arrived. The Twitter hashtag is IOE Lectures, #IOE Lectures, or one word. And we're not expecting a fire drill, so if the alarm should sound, our fire marshals will make themselves known to you and direct you to the nearby staircase. And for anyone that can't manage the stairs, please notify the marshals and they'll escort you via an alternative route. So to the lecture. Now, our speaker this evening, as you know, is John Jerram, Professor of Educational and Social Statistics here at the IOE. John's also Director of the IOE's Centre for Quantitative Social Science, QSS, which brings together researchers with expertise in economics, sociology, psychology, and social statistics to examine issues of equality and diversity in education, as well as the workplace, labour market, and wider society. In terms of John's own research, he completed his PhD in social statistics at the University of Southampton. From there, he joined the IOE in 2011 and was appointed professor in 2017. So a very swift trajectory. John's known for his pioneering research into cross-generational social mobility and inequality in education, but particularly so for his work analysing the OECD's PISA data. Now, for the uninitiated, the Programme for International Student Assessment, PISA, is a triennial test of 15-year-old students across the world in reading, maths and science that provides comparative country-level data on their performance. John's been analysing PISA data for over 10 years and has worked at the OECD itself as a Thomas J. Alexander Fellow. He was the lead author of the PISA 2015 national reports for England, Wales and Northern Ireland, and published widely using those data. In 2013, John was the first recipient of the ESRC Early Career Outstanding Impact Award. And that recognised John's finding that the political rhetoric at the time of England having fallen down the PISA rankings wasn't based in statistically robust analysis of that data, and that was therefore problematic as a means of shaping and framing education policy. Those who know a little about John's work will also know that he's a prolific blogger, and his efforts in that respect are actually hugely valuable in supporting more informed media coverage and debate about PISA. And that's something that this evening's lecture will also contribute to, taking place as it does on the evening before the latest PISA results are published. And at the end, unusually for a professorial lecture, there'll be opportunity to put your questions to John, so please do have some ready. And without further ado, I'll hand over to John to present his lecture. John.
What an introduction, Becky. I don't know if I can live up to that. I always remember when people give me kind of one of these introductions, a time I visited the United States a couple of years back, and they really give you the good push at the beginning. It reminded me of that, and it actually was better than that time because Barbara Schneider was the professor that introduced me there to the group, and she said, "Here's John. He looks like an undergraduate, but, you know, he's actually all right. He's actually all right. He does some good stuff. He does some good stuff." So, yeah. Thank you very much for such a humbling introduction. So the PISA results are here. As Becky kind of suggested, this is kind of one of my main areas of research. This topic's all going to be about, well, can we trust the data that's coming out tomorrow? I feel I'm probably quite well placed to answer this question given my kind of dual hat when it comes to PISA. I don't want to say schizophrenia when it comes to PISA, but almost kind of like that. As in, I use it both for my kind of substantive own research questions to answer about education policy issues, both in the UK and globally. So I'm a user of the data, but I'm also in some respects a critic of the data and have tried my damnedest, basically, to understand as much of the methodology as is possible. So hopefully I'm well placed, therefore, to kind of give a balanced account. Now, a heads up, most of this lecture is going to be critical because I want to try and get people, when some of the results come out tomorrow, to kind of think a little bit more inquisitively about some of them. So as Becky suggested, PISA is an international study of 15-year-olds conducted across a large range of countries now. It's been conducted every 3 years since 2000, so tomorrow's the 7th time the results came out. Its core business is reading, maths and science, although it's now moved into other territories. Global competencies, the new thing, but also problem solving and financial literacy. And one of the reasons why I guess a lot of people are here today is that it's widely known, it's massively influential, and it's very much in the media eye and closely watched and scrutinised by policymakers. We're in election season, so I'm guessing whatever the results show tomorrow, there's going to be some electoral spin put on it. Again, we've got England, Wales, Northern Ireland and Scotland participating in PISA, so you can see the number of different ways it can kind of be sold or spun to people. Now, if you want a prototypic boring country in PISA over the last 10 years, actually it's England, despite all the attention it gets here. So this is the PISA results for reading over since 2006. Basically, stable trend over time in England, not much different to the OECD average, and frankly, it's the same for maths and similar in science, where we're above the OECD average by a bit, but it's been a stable trajectory over time. So it's really been nothing to get excited about, despite everyone getting quite... It's kind of like Christmas time, right? I feel like Father Christmas, and people only care about me one day a year, and that's when the PISA results come out sometime in December. But there's really nothing to get excited about. But despite its kind of huge influence and closely watched nature across countries, there's been some methodological criticism of PISA. Sample design and response rates, i.e. do you get enough schools to participate, do you get enough pupils to participate? Cross-national comparability of the survey. So if you ask a maths or a reading question in England, does it mean the same to kids here as it does to kids in Japan, in Chile, in Africa, wherever? I'm going to talk about, if we get to it, the second half of the lecture, about the scaling model in PISA, which is something that most people in the street have absolutely no idea about, but could potentially be quite important. The low-stakes nature of the test. So this isn't like kids in this country doing a GCSE exam where they've got really a lot on the line and really driven to do well. There's nothing riding on the results. Kids and their schools don't even get the results back, necessarily. So, you know what? So what if I do badly on this test? It's not going to count for anything. And then I've done a paper as well about the comparability of paper and computer tests. So PISA was an assessment done just on paper between 2000 and 2012. 2015, it moved to a computer-based test, and 2018, it moved to a computer adaptive-based test. Now, actually, if you go to the educational assessment literature, they're not the same thing. If you do a test on paper, it's not the same as doing a test on computer. So there's been some criticism, partly from me, kind of around that, and the methodology kind of surrounding that. But what I'm going to look at in this presentation is work that I've done with colleagues in this room, and with PhD students that I have at the moment as part of a European fellowship. The first one around the cross-national comparability using Canada as an example. So Canada was the top performing OECD country in reading in PISA 2015, and it's been kind of flagged as a kind of, a high-performing jurisdiction that we might want to kind of live up to. Canadians have already criticised me for thinking about Canada as one system, but we'll leave that to the side for the moment for another day. Then in the second half, I'm going to talk about how PISA scores are actually created. And this may surprise most people. Almost nobody knows exactly where the OECD's numbers come from, and that's including me. And I'll get a little bit more into that. The key thing around this is, right, if the methodology changes slightly, this opaque methodology, do the results change? And we'll get into that a little bit. So study one, is Canada really an education superpower? So this is based upon, in some respects, the idea came from this newspaper report back in 2017 when Sean Coolan from the BBC actually rang me up and said, Canada does pretty well in PISA. John, what do you kind of make of that as the reasons? You know, it's top performer in reading and it's top 10, one of the few countries to appear in the top 10 for maths, science and reading. It also has low inequality. So I kind of came out and did what I tell people never to do, and that's kind of come up with kind of some explanations and some things. So I say, well, it's an excellent country, it's got low inequality, it's got fairly high immigrant population, you know, maybe they're motivated really strongly to kind of succeed on the test, etc., etc. So I kind of came up with all this. And I thought, this is a good question. Canada does seem quite interesting. Maybe I should write a paper about it. So I initially came to this idea of writing a paper about why is Canada an education superpower? And my first kind of advice to anyone, if you follow me on Twitter, I've been putting this advice out today, saying the first thing you should do before jumping to conclusions from rankings is to go and check the methods behind it and make sure that your kind of assumptions are right. So that's what I did with this paper. I went back and thought, well, is Canada really an education kind of superpower to begin with? Looking and closely scrutinising the methodology that was used in this country for PISA. So that's the question where I essentially asked, how robust is the evidence that Canada is an education superpower? Now, this is how PISA gets interpreted, and when you see the newspaper headlines tomorrow, this is how everyone will interpret it. And just say we've got a country of interest, and for this purpose it's going to be Canada, and just say we've got a country we want to compare it to. And I've just come up with, let's say we want to compare it to Japan, with the idea that Japan is another very high-performing country and is an education superpower. And we want to compare the achievement of 15-year-olds between these two countries, right? Now, we can't test every 15-year-old in Japan and Canada. What we would ideally like to do is take a random sample of 15-year-olds in Canada and a random sample of 15-year-olds in Japan, and then compare those two samples one to another. And that would give us a fair comparison between Japan and Canada. In theory, that's absolutely great. There's not a problem with that. That will give you fine, kind of reliable results. The trouble is, in practice, it ends up not being as straightforward as this, right? There's problems along the way. And there's a series of steps that go from, okay, we've got all 15-year-olds in this country, through to the final PISA sample, and I'm going to walk through each of these. But in short, there's issues with school enrollment, issues with kicking kids out of the PISA sample because of various reasons. There's problems with schools saying, no, I don't want to participate in PISA, and there's problems with pupils saying, we don't want to participate in PISA. And all these things combined together can make our comparison between country A and country B, between Japan and Canada or whoever and whoever, unreliable or with greater problems around reliability and comparability. So let's start on kind of this with thinking about enrollment in school. Now, you can't criticise PISA and the OECD per se because of this, or due to this, because they're very clear about this in their technical definition. But there's a difference between how people interpret things and how things actually are. Now, PISA isn't a representative sample of 15-year-olds. It's meant to be a representative sample of 15-year-olds who are enrolled in school. So any kids who aren't enrolled in school, PISA's not meant to be measuring. It's not part of the population of interest. So in England, you can think about kids who are off-rolled, right? We know off-rolling's a problem. If you're off-rolled in year 11, then you're not meant to be part of PISA. PISA's not going to cover you. And in most OECD countries, including Canada, including England, this isn't a huge problem. You can lose up to 5% of kids in some OECD countries because of this. But in some other non-OECD nations, it becomes a lot bigger problem. So here's kind of an example that I use, which is kind of a hypnotic international ranking, and the curious case of Vietnam. So this is from, again, a BBC article back in 2015, actually written by Andreas Schleicher, head of the OECD PISA Programme, where he talks about Vietnam's stunning rise in the school standards. I'm not quite sure how it's a rise because it was the first time they participated in PISA, but I think what he meant to say was, look, Vietnam does well, essentially. That's why I'm not a journalist, slightly less snappy headline. But what we see here is Vietnam, if you like rankings in terms of science in PISA 2012, scored 528. It was 8th in the ranking. United Kingdom, 21st in the ranking, score of 514. In other words, and politicians, I'm sure, would go, oh my God, Vietnam's beating us. It is beating us in science. It's beating us by about 14 points, which, you know, in PISA terms is kind of reasonably sizable. Why on earth is this? What should we do? Should we go and copy Vietnam's kind of education system? Well, think about this point about school enrollment. The reason why this happens, is because 50%, around 50% of kids in Vietnam, or 15-year-olds in Vietnam, are no longer in school. So they're no longer meant to be covered by PISA, right? And so they're not within the kind of PISA sampling frame, they're not in the PISA population, not in the PISA sample. Effectively, what this means is you drop off a lot of kind of low-performing, lower socioeconomic status kids. What happens if you drop off the bottom tail of the distribution? Your average goes up, i.e. you go up the rankings, and your measures of inequality look quite a lot better. Now, there's a guy in South Africa who does a lot of kind of work around this. His particular interest is PISA and other kind of international assessments, but more focused on lower and middle income countries where they kind of come across this problem a lot in school surveys. And they have various methodologies to try and deal with this based around a set of assumptions. And one of the assumptions they make when trying to correct for this problem is that they assume that any kid not enrolled in school is going to be achieving below the national median, or below the median of those kids that do participate, which is an assumption, but it's not a completely wild one. And from that, they then kind of work out, okay, how do some statistics greater than the median change if we take that into account? So this is kind of what I've done here for the example of Vietnam, whereas along the kind of horizontal axis is the official PISA results for the 75th percentile of, I can't remember which subject it is, let's say maths, of the maths distribution. So this is the score that you need to get into the top 25% of performers in each country. And in Vietnam, that's 576. On the vertical axis is if we kind of adjust these estimates, right, to take into account a lot of children aren't enrolled in school, assuming that they all perform below the median. That goes up here, and Vietnam is kind of an outlier. Their dotted line is where those two scores are equal, i.e. this isn't a problem. In Vietnam, what you end up seeing is a drop of around 50 test points. So this is huge. This is a massive reason why Vietnam does so well in PISA, right? It scores 14 points above the UK in PISA 2012. Because of this, our best guess is that actually it would be about 30 or 40 points. By the way, about 30, 40 points is estimated to be about 0.3, 0.4 of a standard deviation, or if you believe the OECD magic, around about a year of schooling in kind of real term, in kind of absolute terms. So Vietnam would essentially go from being above the UK to quite far below it, just because of this problem of school non-enrollment. So that's a bit of digression to talk about Vietnam. How does this play into how it looks across OECD countries? Well, like I said, this isn't a huge problem across OECD countries. Most places, 98, 99, 100%. The average OECD median's 98% are enrolled in school. Japan, 98% enrolled in school. Canada, slightly below. It's about 96%, enrolled in school. So this has some bearing on the results for Canada, but probably kind of not a huge deal. Okay, so we've gone from we're testing 15-year-olds in the country to a more subtle definition of we're testing 15-year-olds enrolled in school in a country. So what happens next? Well, we don't go and run and draw our sample now. There's a step before that. And that's actually we get to exclude some people from our sample, if we so wish. And why would we wish to do that? Well, in the survey literature, there's kind of usually two reasons. The first is school exclusion. So think about a country like Norway, right? And that school right to the north of Tromsø, where there's kind of 4 people there, and you get sampled to kind of test in that school. Well, hugely expensive, very, very kind of small numbers, not worth the kind of time and effort to kind of actually have in the sample. It's not going to change the results. So schools can get excluded for that reason, although, to be honest, that's usually a real minor thing for some very small schools in some very remote locations. That's not the important thing. The important thing is special educational needs. You can exclude some kids in your country due to them having special educational needs. Now, the problem is, right, what's a special educational need? How it's measured, how they're treated, may well be something that differs across countries, right? Now, the OECD has a rule that says, well, we're going to limit your exclusions to 5% with the view that, and I'm not quite sure how they come up with this figure, but if you only limit it to 5%, then that can make a difference between a swing of 5 PISA test points. Now, 5 PISA test points isn't huge, but it's not tiny either. And the problem is, right, just say you've got country A, Japan, that excludes no one, and country B, that gets to exclude their 5%, that could well cause a difference in the results, right? Put it another way, you have 2 identical countries, absolutely identical. Country A includes everyone, country B excludes their special educational needs kids. Country B is going to have a higher average performance and is going to have less educational inequality. So how does this play out in reality? These are the exclusion percentages across country in PISA 2015. Japan excludes about 2%. The OECD average is 3%. Canada actually breaks the rules. Canada excluded 8% of their sample. So going back to this rule, if that's plus 5 minus 5 PISA test points, my guess is that this might be plus minus 8 PISA test points due to Canada kind of excluding a lot of people, right? So let's think. We've now gone from testing all 15-year-olds in the country to testing only those 15-year-olds who are enrolled in school and kicking out some kids with special educational needs. Now what do? We draw our sample and we try and recruit the people, the schools that we've selected into our sample to actually participate in the study. So we go to schools and say, please, 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 you've been selected. Please take part, otherwise we may not have representative data. And again, the OECD set rules around what percentage of schools you approach that have to take part for your data to be considered, in their view, representative. Now, because it's the OECD, it's not as straightforward as that, and there's a few smoke and mirrors go on as well, which I'll try and walk you through to try and get people to understand. If you get above, so running along here, the horizontal axis, is the percentage of schools that were selected to participate in PISA that actually end up taking part. And this dotted red line going up here is at 85%, which is the OECD's rule. You're meant to get 85% of your schools or more to participate in the study. And if that's the case, which it is for the vast majority of schools, right, then you're in. You get to take part. If you get 65% or less, you're kicked out. You're not meant to be involved. Your data's not representative because 1 in 3 schools that you've approached to take part in PISA have basically told, no, you can't do that. Now, what happens if you get between 65 and 85%? And this is where it's that kind of grey, murky area. What basically happens is, well, for those, if you fall in between this region, for those schools that said no, they have a replacement. So they can be essentially substituted for another school that looks similar in terms of observable characteristics. And those observable things about the school depend upon the country. So in Canada, for example, it's only stuff like school funding, public-private, things like that. So you can use that to get you up from 65% to above the 85%. That's not technically correct. Actually, the kind of these replacement schools, they kind of up the percentage that you need, but it's kind of broadly right for this purpose. If you still fail to get above the threshold, even including the substitute schools, what happens is you're meant to submit a non-response bias analysis to the OECD. Now, what the non-response bias analysis is you or the country going to the OECD saying, look, there's no bias in our sample, here's the evidence. There's not really strict criteria around kind of what's in it, and it's pretty much up to the country to decide what they submit as far as I could see. So I know if I was in that problem, I'd be not looking too hard for problems and looking more and more for solutions. But that's kind of what's meant to happen. So going up this vertical axis here is the percentage response rate after those replacement schools that I spoke about are included. Now, there's a few interesting things around this. Firstly, Canada, our country of interest, after the replacement schools have been added in, they have the lowest response rate, school response rate, essentially, of any country. And there's countries like this, like the Netherlands. So the Netherlands was meant to be kicked out. It was meant to not be able to do a non-response bias analysis. Not the case. It's fully there in the PISA 2015 results reported as if nothing's going on. You have to go to the depths of the technical appendix to find out any more details about it. I should also say about these non-response bias analyses is that they're not freely available. They're not published by the OECD. And if you go to the technical report, all you get at most is one slightly nebulous paragraph about these countries saying kind of what's in there. Unless you're like us and know how to use freedom of information rules, where we've managed to get copies of these for the Netherlands, Canada, New Zealand, and Netherlands, Canada, New Zealand, and I had one more, for the UK back in 2009. So it's not quite as straightforward, i.e. PISA and the OECD will often tell you that 85% of schools need to take part, but is a bit more fuzzy than that. Now, these non-response bias analyses as well, because I'm a PISA nerd, I've gone back through and seen how many times countries have been excluded, how many times these response thresholds haven't been met, and how many times that these non-response bias analyses have actually had bites. Are they actually going to follow through with their rules to kick countries out? Well, as far as I could see, there's been 24. I don't have the results for tomorrow in there yet, just to let you know. 24 of these have ever been conducted. Only 3 out of those 24 times has a country been kicked out. The Netherlands in 2000, when its school response rate was 27%. Fair enough. We're not going to argue too much about that. Malaysia in 2015, where the response rate was 51%. So again, half the schools that were meant to be in there didn't participate. And has been well publicised, UK in 2003, where it was 64%, so just below that kind of 65%, you're definitely out threshold. Now, there's a few things to kind of notice about that. Firstly, this non-response bias analysis is meant to be for countries between 65 and 85%. Whenever it's been used to kick countries out below that 65%. So actually, if you get 65%, it's not 85% and above that will get you in, it's 65% and above that will get you in reality. And like I said, they don't publish the details of these, so they just basically kind of give you a nod and say, yeah, you're through, rather than kind of anything else. And this is just showing how this kind of plays out for our countries of interest. So in Japan, this is the school response rate after replacement. In Japan, it's 99%, but even before replacement, which is the proper response rate, by the way, is well above 90%. For Canada, bottom of kind of all OECD countries, it's 72%. So, even after replacement schools are included, around 1 in 4 of those schools that are meant to be taking part in PISA in Canada don't. And finally, now we've got our sample of schools, be it dodgy or not, we have pupils, right? Pupils are there within schools. But pupils or their parents may say, actually, no, you're not participating in the study. So it could be parents taking them out and saying, no, you're not doing PISA, or it could be students who are actually absent on the day of the test. And again, that varies massively across country. And this is actually one of the areas where I think there's probably biggest bias introduced into PISA. Canada, very low, compared to other OECD countries. Only 81% of those pupils who are meant to take part in PISA do. So think about a class of 30 people, about 1 in 5 in that class of 30 don't take part. So you're dropping out 6 kids who happen to be absent from the day of the test, kind of from the PISA study in Canada, compared to, say, Japan, where you've got 97% participating. So now we've gone through all those steps, we're at our final PISA sample, right? So we've only got kids who are enrolled in schools. We've kicked out some kids with special educational needs. There's been some schools that have turned us down. There's been some pupils that turned us down. And we're at now the final kind of PISA sample. Now, actually, let's go and think about what the PISA rules actually allow you to do. And I'm going to ignore this problem, the enrolled in school problem, because like I said, PISA is actually clear about it. And to be honest, there's not a huge amount that could be, more could be done about it in OECD countries. Well, the rules allow you to lose 5% from pupil exclusion, so from special educational needs. It allows you to lose 35% due to school non-response. As I showed you with that bias analysis, at 85%, you can get 65% response rate and still get through. And you can lose 1 in 5 pupils due to pupil non-response. So if you multiply that through, you start with 100% of the population. You multiply that by 0.95, which is 100 minus that. Multiply by 0.65, which is 100 minus that, and 0.8, which is 100 minus that, you end up with about 50%. So you can end up losing around 50% of whoever's meant to be in there from the various stages that you go through, according to the rules, and you can still be allowed to participate with no questions asked. Now, this isn't only a theoretical issue. This is something that kind of plays out in practice. So within the depths of the PISA report, and these are the first pages, everyone else turns to the headline findings, how it's average achievement looking over time. I turn to this. I turn to the nerdy details right at the back. And in the annex, it gives you the size of the 15-year-old population within each of these countries, and it gives you a number for the percentage that were actually assessed. And actually, these numbers are still upwardly biased in my view, but I won't go into that now. So this kind of gives you an idea about how it plays out in reality. In Japan, about 91% of the entire population essentially, to some extent, covered or whatever as part of PISA. Whereas if you look at Canada, comes out right down the bottom where you're down to kind of 53-ish%. So this is kind of borne out in reality. So is Canada education superpower? I haven't kind of answered that question. I've only told you why to be sceptical. And the difficulty with answering this question is, right, we don't really know that much about the characteristics of who drops out at each stage. If it's just absolutely purely random, then it may not necessarily be a problem. Of course, you should be sceptical about whether it is random or not, because clearly, kids with special educational needs aren't random. Kids who tend to be absent from school aren't random. They tend to generally be lower achievers. The problem with not publishing the bias analyses is, well, you don't know kind of a lot about these. So what we've done is basically run a simulation to say, how would the Canadian PISA results change under various different assumptions about how those kids that aren't in and were meant to be in, how they would have performed. So in this top row up here, we have the kind of official PISA scores for Canada, where in column 2, they scored column 3, the average score is 527, and the difference between the 90th and 10th percentile, so the difference between the highest and lowest achievers is about 238. And we go through various different assumptions in the paper about how those non-participants, those kids that were meant to be in there but not, how they would have performed on PISA had they have been in. And we go through various different assumptions. We think this one's kind of fairly plausible. So those kids that aren't in there that should be score on average around 480 on the PISA test, so a bit below the OECD average, but not by much. And under that scenario, you kind of drop Canada by about 20 points, so it's around about not much above the OECD average. So what we end up thinking about Canada, I think, in this terms, and educational inequality rises as well. So what we end up thinking for Canada overall is probably the headline PISA results are very much an upper bound, and we think the reality is that it probably gets more towards the OECD average once you think about and take all these problems into account. And we think that there could be quite fairly large swings quite a lot of uncertainty in the data for Canada, and a lot of different things could be plausible. Why am I telling you about Canada? We're in the UK. Why is this important for the UK tomorrow? Look out tomorrow, and I promise I don't have the inside track. Look out tomorrow for how these things might apply to England and the rest of the UK. So my sources, multiple sources, has suggested to me that a non-response bias analysis has had to have been done for the UK sample. So keep an eye out, and if you can't see something that jumps out to you in the findings, think about the methodology kind of part of it beforehand, and see if the Department for Education have published the non-response bias analysis that they submitted to the OECD. So these are kind of things that could play out tomorrow. Okay, so that's stuff about the sample. Let's talk a little bit more about how PISA scores are actually created, and does this matter for results? Let's start with a show of hands. Who's opened the PISA data set in the room, the microdata? Yeah, about a third maybe? I saw some people kind of half hands up, half hand down. Like, I kind of think I have, but I'm not overly sure. I kind of know what you mean when you kind of say that. The answer to these questions, by the way, is how are PISA scores actually created? I don't really know for sure, but I think I get kind of close. The key thing is almost no one does. And actually, I would go out on a limb and say no one in the UK knows precisely how all the figures everyone will jump up and down about tomorrow are actually created. I'll go into a little bit more about that. And does this matter? We think so. We think so. Particularly for measures other than the average, and particularly for the subject that's not the focus of PISA. So in PISA, one subject is the focus each time. Tomorrow, it's reading. And we think that this can matter more in tomorrow's case, will matter more for maths and science and for measures of education and quality rather than the mean. But let's go through it a little bit more. How does the PISA test actually look? Now, PISA's marketed, right, of essentially a test of reading, mathematics, and science. And I think most people's presumption is, okay, kids take test questions in reading, maths, and science, and each kid gets some reading questions, some maths questions, and some science questions. That's not actually how it works. So what happens is the PISA test, historically, it's changed a little bit in the most recent round, is divided into 13 separate booklets, using this example from PISA 2012. And each child gets randomly sampled 4 clusters of questions, and each cluster is 30 minutes long. So take booklet 1. Kids start off with half an hour of maths questions, move on to half hour of science questions, move back to half hour of maths questions, and then move back again to 30 minutes of science questions. So maths, science, and kids are randomly assigned to that book. Similar for booklet 2, some kids are randomly assigned to it. They start off with science, move to reading, go on to maths, then move back to reading. Now, I've highlighted here booklet 10, where you can see actually what they do is an hour and a half of maths questions, a little bit of science, half an hour, but take absolutely no reading test questions, right? But what happens if you open the PISA data file, and those of you who have done it will kind of know this, is just say these are kids that have taken that booklet 10. What you'll see in the data file is 5 reading test scores appear for them. So they haven't taken any reading test questions, but they have 5 reading test scores, or what look like reading test scores. In the literature, they're known as plausible values, within the actual PISA data sets. Why this happens is PISA is essentially built on mass imputation, i.e. multiple imputation on an absolutely giant scale. And what that actually means is, well, this is kind of a simplification of the statistical model lying behind PISA and how the scores are created. For those kids that took booklet 10, their reading scores, which is denoted by this oval, are basically predicted off the basis of how they did in those maths questions, so that hour and a half of maths, that 30 minutes in science, and then what's called in the literature conditioning variables, which is essentially all the information that PISA collects in the background questionnaire. So stuff like their gender, socioeconomic status, attitudes towards school, life satisfaction, all things like that is used in that prediction model for those kids' reading test scores. Does everyone follow that? You're all nodding. You're so much better than me because I can't understand it. I've been doing it for years. But yeah, it's not as straightforward as the rankings in the newspaper or the man in the street kind of perhaps expect. Now, why should you care about this kind of oddness of the methodology? Well, it's all based around predictions, essentially, from a statistical model. And as any good statistician will probably tell you, there's no one single right way. And even if there is one single right way, we probably don't know what it is. So we would really worry, right, if we start changing this model that's used and the results change. And we would argue, particularly if we change this bit of the model. If you change how those conditioning variables, how the kind of gender, socioeconomic status, et cetera, are used in the prediction, and you get different results, that should still alarm bells ringing. Secondly is, almost no one knows how this process exactly works. We kind of know roughly how it works, and we get pretty close to replicating it, which I'll talk about in a second. But it's really, really, really complicated. It's probably the most complicated thing that I've come across in my academic career. And actually, I make kind of parallels to the financial crisis of 2007, 2008. And I do that by kind of thinking, well, what crashed the system in finance? Well, it was all these very clever people doing very clever things with financial derivatives that no one actually else could understand. It all got tied up in such big knots that, it all kind of unraveled. It does feel a little bit like that here, where you've only got 4 or 5 people, and I mean this literally, 4 or 5 people probably in the world that really, really know what's going down to the T. You need specialist hardware and specialist software to actually run this model, because we're now trying to run it, or our version of it. And we can't do it on the UCL Safe Data Haven, we can't do it on our own laptops. You have to go into the supercomputers that the computer science geeks, specialists, whatever, use kind of in central UCL to really kind of crunch it. So it's really kind of computer intensive as well. Number 3, I could rant about this for an hour. The OECD will not tell you how it works, i.e. we've sent our paper to the OECD back in September and said to them, look, will you show us the code? Will you show us where you get your numbers from? Nope, no response. Well, they've either said no or not responded to that part of the question. We've emailed ASA and ETS as well, sent them the paper, and essentially got no response. So they won't actually tell you how it works. We don't know if anyone can actually fully replicate PISA test scores. And let's tell you a secret from when I wrote the PISA report in 2015, right? So it's about a month, wasn't it, Nikki? Yeah, you can't believe I'm going to say this, can you? No. It's right, we're no longer on the contract. It's great. It's not like it's being recorded. About a month before the PISA 2015 results were out, we had the report written. England was top of the world for biology, or near the top of the world for biology. Then we get a bit of a panicky email from ETS and the OECD saying, yeah, about those scores that you've got for the subdomains in science. Yeah, someone pressed the wrong button somewhere. So we were no longer the top for biology. The report was damn well written, and we were going out and kind of publishing it. I think ministers may have already been briefed. So people kind of had to very hurriedly run about and kind of say, oh, no, actually, that's not correct. Now, there is a kind of an issue lying behind that, right? There was about 80 different countries looking at this stuff. The OECD were looking at it. I was looking at it. Several hundred people looking at it. No one spotted it. So that, I think, tells you something about kind of how much people actually understand kind of what's going on. So there's reasons to care about this. So what do we try and do? By the way, this is the royal we. I've got an excellent PhD student who has been spending a year kind of working with me on this. So when I say we, I mean 2% me. That's a bit generous to me, and 98% Laura. So what we try and do is recreate the PISA 2012 scores from scratch, i.e. we try and recreate this absolutely crazy model on the kind of supercomputers here. Then we fiddle with the model, right? And we particularly fiddle with this aspect of the model. So we change how these conditioning variables, these background variables, enter in the model, with the idea, like I said, that if you play around with this and the results change, it kind of starts ringing alarm bells. And then once we've fiddled around with stuff, we go back to investigate how cross-country comparisons change under the different versions of the models we run. So basically a giant set of robustness tests looking not only at mean scores, the headline PISA rankings, but also measures of educational inequality as well, difference between 90th and 10th percentile. We do some stuff with gender and immigrant differences, which are in the paper, but we're not kind of publishing today. So these are our results. This is kind of our attempt. Are PISA 2012 scores replicable? So we've got the results here for maths, reading and science. Going along the vertical axis are the official PISA scores. Each dot represents a country. So these are the things that you see in the official PISA report. And along the horizontal axis is our self-computed PISA scores going through this kind of entire process from scratch. Now, in maths, what you want to see is the dots basically on this 45-degree line. That means we've got it right. For maths, we're sorted. Correlation 0.998, all the dots are on the 45-degree line. It all seems to work pretty well. Remember, this is PISA 2012, and maths was the focus subject. So if we go back to the test design, there was a lot of kids doing a lot more maths than the other subjects. So the fact that we can replicate it probably isn't a surprise because there's less work being done by the imputation model, yeah? It's being more based upon kids' actual responses to test questions. For one of the minor subjects, science, we get kind of a similar finding. We're kind of okay with it. Correlation 0.995, you're generally pretty happy. Most of the dots are on the 45-degree line. Where we see some issues arise is reading, where essentially the correlation's lower, 0.94, still reasonably high, but there's some kind of fairly big swings in some of the countries' results. Now, in some ways, this is an odd finding because this is all run as one giant model all at the same time. So the fact that we get it bang on there, but not there is kind of interesting because you would think if there's kind of some kind of coding error or we've done something stupid, they would flag up there or certainly there. The fact that it's only in this subject, I think, is kind of possibly telling us something. Yeah, go for it, Sam.
Sorry, is this just you fiddling with the model to try and get the R statistic as high as you possibly can?
No. So this was just basically getting the PISA technical report for 2012 and following that as closely as we can. So it wasn't us trying to kind of, let's try and maximize the R squared on this correlation. This is, let's follow what they say they do and try and replicate it as best we can. Yeah. So can we reproduce PISA test scores from scratch? Well, partly yes, but in some subjects no. Now, if we fiddle with the model and do different things, and in particular, if we change about how that background data, those conditioning variables are used, does that change the results? Now, this is the results, I think, for science. It holds for maths as well. Along here is all the countries. The circular markers in this graph is where we say we use no conditioning, i.e. all those background variables, we just kick out of the model. We don't use them in the imputation at all. We're basing it purely upon how kids answered the test questions. And the triangles where we do what we call full conditioning, i.e. we try and do exactly what OECD did. And what you should be able to see in this graph for science, very similar for maths, is that the circles and the triangles pretty much fall on top of each other, right? There's not much difference in the results. Actually, the model that we use doesn't make much difference. Now, again, that should really be the case for maths in particular, yeah? Because there's not much going on in the imputation model because kids have answered a kind of a lot of questions. But bearing in mind reading's the focus subject tomorrow, we see big swings in the results for reading, changing kind of what we do. So let's take this country here, which is, I'm going to say Iceland. You see kind of a big drop in performance from kind of about 30 test points, depending on what you do. And this is kind of reflecting a more general pattern that we see for reading, that we've tried 8 different versions of this conditioning model and got quite large swings in the results. Now, going back to kind of this finding, the fact that we haven't been able to replicate completely the results for reading, and we find big swings in the average scores for reading, we kind of think that might be two sides of the same coin, as in, if you get the model slightly wrong, or we get our replication slightly wrong in maths and science, actually that doesn't matter too much. We still get pretty much what the OECD does. But the fact that when we fiddle with our model, our results change quite a lot, it probably means, well, yeah, our replication isn't as good because the model seems to matter, at least for that particular subject in that particular wave of PISA. And this is how the PISA 2012 rankings look for the mean under all our different kind of conditioning model specifications. So M0 there is where we don't have these background variables used in the computation of PISA scores. M7 is where we try and do exactly what the OECD has done, and M1 to M6 in between is where we try lots and lots of different ways of doing it, which I'm not going to go into the details about exactly what we change and how. Green shading means higher ranking, red shading means lower ranking, and so the idea is, well, you should be able to spot the colours horizontally, and where there's large swings, i.e. when there's large differences between red and green horizontally, you can see big swings in the results. So a good example here, right, is Sweden, where you can see actually it does comparatively badly under some specifications, but pretty damn well compared to other countries under other specifications for the average score in reading. So we think there's kind of something going on there. What about measures of educational inequality? So we're going to look at the gap between the 90th percentile and the 10th percentile. So can PISA be used to measure educational inequality across country? This is very similar to the table that I've just shown you. Apart from this is now the gap between the 90th percentile and the 10th percentile under loads of different ways of deriving the PISA scores. Green shading is now lower inequality, red shading is bigger inequality, and what you can see again is some pretty big swings in the results. This is, again, reading. You can see Norway goes from having pretty bad inequality on PISA to actually what looks like pretty low levels of inequality on PISA. So again, the model seems to matter. The most interesting thing about the inequality, and it's probably our most robust finding, which I'll say a bit more about in a sec, this doesn't just hold for reading now. Whereas the results in for the mean just was a problem for reading, we can go to the results for this is maths, and we see big swings here as well, and we see the same in science. So if we're focusing on the first moment of the distribution, the mean, actually things don't look too bad apart from in this one subject. If we're using PISA to compare educational inequality across country, we do see some big changes in the results depending upon exactly how the scores are created. So the key takeaway question is, we think the model matters, and the finding that we're most sure about is this: we should be sceptical, I think, about the robustness as a tool to compare educational inequality across countries, just because for each of reading, maths and science, we're seeing countries' rankings and substantive results change depending upon exactly how the scores are derived. And we think the OECD needs to be a lot more transparent about how the PISA scores are generated. They need to say or need to publish their code, and we're trying to follow best practice when we actually publish the paper, which will be soon, on Laura's GitHub website. We're going to publish our code. If you think we're wrong, feel free. Feel free to go in, take our code, show us exactly where you think we're wrong and why the OECD is right. So we're trying to kind of promote the transparency around this. So, conclusions. Should we trust PISA and other international assessment data? Well, actually, all the stuff that's going to come out tomorrow, in my view, isn't the benefit of PISA, isn't benefit of any of these international assessments. Actually, differences across most of these countries in terms of magnitude are quite small. So you see a 10-point difference in PISA actually moves you quite a bit in the rankings. It's made out to be a big deal, but that's 0.1 of the standard deviation. It's not, in magnitude terms, actually that big. And in my view, if you get a swing of up to 10 test points, mixture of sampling variation and methodological changes and non-response varying over time, you can probably explain away a 10-point difference fairly easily, even though there's never been that much change over time. And even if there was, is it that much policy use to know that kids in England aren't as good at maths as kids in Japan? I don't know. But in my view, that doesn't mean that the data aren't incredibly valuable. And I know this has been negative, and there's a reason for it to be negative, because I want people to be cautious about when interpreting the results tomorrow. That's not to say the results are no use at all. So if you think about this country and its education data, we have great education data. We have the National Pupil Database. In many ways, it's the envy of the world. One place where our education data is weak compared to a lot of other countries is being able to link teachers to pupils. Actually, we have the TIMSS data set, which, as far as I'm aware, is the only data set really in the country where we've got a nationally representative sample where you can link teachers and what teachers do to individual pupils. So that's incredibly useful. PISA now is the main way to compare educational achievement, in my view, across the UK. So if we want to compare England, Wales, Northern Ireland and Scotland, PISA is probably the best tool that we have, which is becoming more and more important, right, as assessment systems change across the countries. England's now got the 9-to-1 system. Other parts of the UK don't, so PISA is our best way to kind of compare. PISA also collects incredibly rich background data, both from students, in some countries teachers, and from head teachers. It can tell us a lot about school policies and practice. And critically, I think, and where it's really underused, is helping us understand about Year 11 pupils. So the timing of PISA is such that all the kids in at least England and Wales in Year 11, they take essentially an assessment in November and December, then they take their GCSEs for the following June. So essentially, you've got a questionnaire during GCSE years given to a kind of representative sample of pupils where you've got rich data on reading, maths and science collected, but also their GCSE outcomes. And I think there's huge kind of research opportunities to do with it. And actually, there needs to be more focus on that. And that's the real use and the real value of this data, kind of, in my view. I'm almost out of time. I'm going to take the last 2 minutes to say thank you. Thank you to everyone I've named on this slide, and lots of people that I haven't named on this slide that should really be on there, but particularly Laura Ziegler, who's not here, but essentially did a lot of that work on that kind of second paper with me. Nikki, Jake Anders, Sylvan Hass, who are sat over there, who've worked for me particularly closely on the paper about Canada. The guys at Education Data Lab, who have collaborated with on for many years, collecting data and writing blogs, etc., etc. And I should also give a shout out to Tom Benton, actually, at Cambridge Assessment, who we've shared papers, code and view with, particularly Laura and I, on that second paper. So conversations with him have been kind of actually very helpful. Thank you. Yes.
John, that was so stimulating. Thank you. I love it. I feel very proud, actually, that in this room, a third of you have looked at those data sets. For the 2/3 of us that haven't, I think we're very grateful to you all. But that was absolutely fascinating. You know, this mystery about how the scores are created, that reading doesn't actually measure reading. This is going to be very interesting with the results coming out tomorrow. And I think the encouragement of, you know, caution, as John puts it, rather than perhaps avert scepticism, is really, really important given the inference that PISA is imputed across to educational policy by our policy makers. So having this encouragement of transparency and caution, as well as the education for us all, John, in how to nuance and be cautious about these statistics is really important, I think. And we'll be very much looking forward to the Jerem model of your plausible assumptions the Ziegler Jerem model of your new rankings. I'm sure there's a lot of money to be made there. But we're going to have we've got some time for questions now, and we'll probably take a couple at a time if that works okay. So a show of hands for anyone that would like to ask John a question. We've got one here and one over here. And we've got the mic, I think, haven't we? please, Loic, go ahead.
Okay,
And
thank you. Hiya. One first technical one, and on the conditional variables, are they country specific? So do they reflect differing trends between countries and say boys and girls attainment, or are they using the same ones across countries? And secondly, when you come up with these critiques, would you characterise the OECD's response as one of kind of scholarly peer review or one of defensiveness?
Thank you very much. And one over here.
Thanks. Can you, because you mentioned about education inequality in terms of the reading scores, can you clarify how does the swings in terms of reading result relate to inequality? Thanks.
Thank you very much. And another one from David here. Kate, thanks.
Thanks, John. A slightly geeky question. You mentioned early on the Rush model or item response theory. I would have thought that differential item functioning is a big issue in doing cross-national comparisons because there can be big differences in the priority given to different types of programs in reading and maths and science and so on. And so item difficulty may vary cross-culturally, and how does that get handled here?
Thanks so much. So some good questions to start with. So country-specific variables to start with, John.
The simple answer to that is everything's run separately by country, and almost in every country, almost all the variables are the same. There's a few differences in terms that each country actually, at the end of the PISA questionnaire, gives 5 minutes to ask their own national questions, and they will be shoved into the model as well. So there'll be some kind of differences between countries. But yeah, it's all run separately by country.
And do you want to just make a response on the OECD's response to your challenges?
I would love to. Actually, it's a mixed response, whereas actually the individual researchers at the OECD, some of whom I got to know kind of fairly well, very much kind of scholarly peer review. And if you get them over a glass of wine with dinner to chat about things, it's kind of very fruitful, and you have kind of good conversations. They're all really nice guys. The institution of the OECD is a different matter, and it's kind of a lot more kind of cagey and cautious and very, very sensitive is the phrase. I've got on very good authority that Andreas Schleicher does not like me. And I think I'll leave that question there.
This is now on film.
Hi, Andreas.
We had a question on inequality.
Yeah, so I don't know if I completely followed your question on inequality. You were saying we saw large swings, and you were saying how does that relate to inequality? Were you talking about income inequality, or I wasn't quite certain on your precise question?
I think you pointed out the inequality element in there.
Yeah.
And then you jumped to the bigger swings in terms of reading scores compared to math and science. How that...
Yeah, so essentially the conclusion from those slides was you see big swings in educational inequality measured between the gap between the top performers and the low performers in reading, depending upon exactly how the scores are created. And you see the same in maths as well. So the kind of headline takeaway from that is how much should we trust PISA to measure educational inequality and compare it across countries, because how the scores are derived in the statistical model seems to have a big effect potentially on the results. So it's more questioning about how robust is PISA as a measure of educational inequality. On David, I love your geeky question. And yes, differential item functioning and measurement invariance is a big topic within PISA. Actually, it's something that's changed methodologically between the different cycles. So a lot of people don't know this, but in PISA 2015, some questions for some countries were excluded from the scoring and from the model, depending on differential item function. And what people don't know is that sometimes stupid things happen because it's all done by computer, essentially, and if you're above or below a certain threshold, you get kicked out. So what happened was some questions that were included in the scoring procedure for England, Wales, and Northern Ireland were excluded for Scotland, for instance, which is kind of slightly a bizarre way to go about it. I have kind of some problems with what the OECD did for differential item functioning for the paper and computer assessment with that change in 2015, where essentially they tried to make things comparable by adjusting the difficulty on the computer items to try and make it more comparable to the paper items. Now, they didn't pick the questions that would be affected beforehand. They didn't say, that question's going to be affected by the move to computer, that one is, that one is. They waited, saw what the data showed, and then, adjusted the parameters to kind of even things out. That's the problem with differential item functioning across country, is that if you take it too seriously, you just smooth out differences. You just smooth out differences across countries and over time. So it's a very thorny issue. And my own personal view of the kind of psychometrics behind that is differential item function measurement invariance isn't necessarily a good way to think about cross-national comparability.
Thank you. And we probably have time for just a couple more very quick questions, if anyone has them. Two here, Lindsay and the lady behind.
Okay, well done. You touched very briefly at the beginning on the point about low stakes nature of the tests, and I mean, there's been a few papers that have been released just in the past few weeks about this. I wonder if there's any kind of handle on the extent to which the variation in how much effort is applied to low stakes tests across countries would change the rankings. It seems like one of the kind of most significant issues in my mind. I know you've done some research on London, perhaps you can.
Mm-hmm. Thanks, Lindsay. And there's a lady just here.
Hello. It just came to mind to me that my brother was complaining about something called PISA-based tests that they were made to do last year. And this was around April, so it wasn't the time where the general PISA tests happened. And they were told this isn't PISA, but it's as important in getting PISA information. So would that have to do with the replacement school thing you were mentioning?
Yeah, so I can take both of those questions. Yes, Lindsay, that's a great point. And actually, if I was to make probably the biggest criticism, methodological criticism of PISA, and it's something that's really difficult to deal with, is low stakes testing. Why should kind of kids bother to try it? And in some countries and some cultures, you're given a test, you do try your best. In other countries, you know what? You don't try your best. And actually, I think it plays out quite well with PIAC, which is the adult assessment in the country. And I was saying the other day, in England, we had a kind of a result where our young people were one of the very few countries, so the kind of under 25s, didn't outperform the over 55s, and we were the only country to see that trend. And part of my view was, well, there's a load of students in that. Are they just more hungover than kind of people in other countries? Similar kind of thing, right? Actually, when nothing's riding on the test, it can cause differences across countries. Now, PISA does have some ways of measuring this. There is a question in the background questionnaire where they ask how much effort did you kind of put into the test. May or may not be great. Now it's on computer. There's something called response time effort. So how many kids tick, 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 on the computer zooms straight through where you can get some more information. There's not been huge amounts of work done with that as far as I could see. There's been kind of some out there. But I do feel that it is one of the kind of biggest limitations and probably what can explain at least partially the gap between the East Asian countries and the kind of Western countries. In the United States, they pay kids to take part in PISA and stuff like that. Yeah, they get, I think it's $25 a pop.
Wow.
Yeah.
Wow. We're learning a lot.
Yeah.
And did you?
I'd do PISA for that. Come on. And PISA for so what you're talking about there is PISA for schools. So the OECD has a program where essentially they go around schools, and actually some schools do it in the UK, where they do it outside the main cycle and say, well, hey, why don't you do the PISA test? We'll give you a PISA score for your school, so you can compare that to other countries, and you can do the background questionnaire. And the idea is you can benchmark your school against national and international averages. Now, it's done in the UK. The trouble was, I actually remember we were thinking about bidding with this with, I think it was with RM actually. And I don't think it was when you were there for. I think you had left by then. But we decided not to go for it in the end because they were trying to charge schools, I think it was $3,000 a pop, the OECD, to do it. So there was a handful of schools did it. I think Westminster was one of the schools that ended up doing it. So it ended up being a load of posh private schools in the UK that kind of ended up doing it that, you know, essentially used it as a marketing device. Hey, kids who go to our school are getting the same scores as kids in the high-performing countries.
Wow, there is a lot to think about there. I know that many of you will have your own questions for John and also will want to take this up in discussion together. You've provided an enormous stimulation for us, John, a lot to think about there, and we really appreciate it. So thanks so much again, and I do hope everyone will join us for a drink and further conversation after the lecture. But let's join in thanking John first of all. Thank you.